Time travel is a widely recognized concept in philosophy and science fiction. But is it possible in real life? What does physics tell us about time travel? Is it possible to travel to the past or the future? Neil deGrasse Tyson explains the nature of time and the conundrums of time travel.
In some ways, we're traveling in time now. We just happen to be prisoners of the present in the eternal transition from the past to the future. If you travel fast enough, you can actually leap forwards in time. Relativity specifies that you travel a good fraction of the speed of light, time will tick more slowly for you than all your loved ones back on Earth. If your journey is too long, you might be gone for 10 years and everyone else on Earth ages 100. So you've effectively gone into the future, and then everyone you knew when you left Earth is now dead. If you want to go into the past, that's a little more problematical. There are people who have recognized what severely distorted space does. The effect, that severely distorted fabric of space and time. They've studied what effect that has on the passage of time. And it turns out there is a path you can take around two moving black holes that haven't quite collided yet, where you can end up in the past of when you started that journey. It's backwards time travel, according to calculations from Einstein's general relativity, is enabled by the severely distorted fabric of space and time, such as what you would get with black holes that came in their own proximity.
There are some physical theories that can help us learn what time travel is and how it works. In 1905, Albert Einstein published the first part of his relativity theory, known as special relativity. The theory of special relativity showed that particles of light, photons, travel through a vacuum at a constant pace of approximately 300,000 kilometers per second, a speed that's immensely difficult to achieve and impossible to surpass in that environment. Yet all across space, from black holes to our near-Earth environment, particles are, in fact, being accelerated to incredible speeds, some even reaching 99.9% the speed of light. He then published another paper in 1915 known as general relativity. These theories are among the most important theories in all of physics. Under Einstein's theory of general relativity, gravity curves space and time, causing the passage of time to slow down. In Einstein's theory of special relativity, time slows down or speeds up depending on how fast you move relative to something else. So for an observer, in an inertial frame of reference, a clock that is moving relative to them will be measured to tick slower than a clock that is at rest in their frame of reference. This case is sometimes called special relativistic time dilation. Time dilation may also be regarded in limited sense as time travel into the future. The faster the relative velocity, the greater the time dilation between one another, with the rate of time reaching zero as one approaches the speed of light. Scientists have done some experiments to show that this is true. For example, there was an experiment that used two clocks set at the exact same time. One clock stayed on Earth, while another flew in an aeroplane going in the same direction Earth rotates. After the airplane flew around the world, scientists compared the two clocks. The clock on the fast-moving airplane was slightly behind the clock on the ground, so the clock on the airplane was travelling slightly slower in time. Another famous experiment is the twin paradox, which is, according to Neil deGrasse Tyson, not a paradox at all. He describes the experiment as a hypothetical scenario which uses identical twins to illustrate Einstein's theory of relativity.
Take Newton's laws, for example. He has a law of motion and law of gravity. Then we find out, wait a minute, and if there's a high gravity source, Newton's laws fail. If you're moving really fast, faster than a running horse, whatever Newton might have experienced in his life, his equations begin to break down. Do you throw away all of Newton? No, it works in all the other cases. So what's going on? Einstein comes up with laws of motion, his special theory of relativity. Einstein comes up with a new law of gravity, his general theory of relativity. Do they replace Newton? No. They draw a bigger circle around the applicability of Newton's laws. Newton's laws apply here, Einstein's laws take over. And even with Einstein, his equations can't take us to the center of a black hole, the singularity that's there, the singularity at the beginning of the universe. We know now that his theories fail. They blow up on the page. So we have a whole frontier of science. The string theorists, we got top people working on this to try to extend Einstein's laws into an even bigger regime that can then explain everything that's in our universe, not most things.
There have been many scientists who have proposed time travel theories that describe how time travel might be possible. Physicist Miguel Alcubierre proposed a theoretical solution to Einstein's equations, which would allow a spacecraft to achieve apparent faster-than-light travel if a configurable energy density field lower than that of vacuum could be created. Rather than exceeding the speed of light within a local reference frame, a spacecraft would traverse distances by contracting space in front of it and expanding space behind it, resulting in effective faster-than-light travel. Objects cannot accelerate to the speed of light within normal spacetime. Instead, the Alcubierre drive shifts space around an object so that the object would arrive at its destination more quickly than light would in normal space without breaking any physical laws. However, the proposed mechanism of the Alcubierre drive implies a negative energy density and therefore requires exotic matter which has physical properties that would violate known laws of physics. What leads people to think that travelling back in time cannot occur in our universe is the grandfather paradox. This is a well-known paradox of time travel, in which inconsistencies emerge through changing the past. The name comes from the paradox's description. A person travels to the past and kills their own grandfather before the conception of their father or mother, which prevents the time traveller's existence.
There are some suggestions about how to go into the past, but you go on a trajectory, a space-time trajectory that does not intersect back with yourself. So you can't really interfere with your own past. And so that requires huge energy to execute. And well, we're still pulling oil out of the ground, so there's no energy anywhere close to acquiring. So the simplest way is to go forward in time by traveling very fast. How fast? A lot faster than any piece of hardware we've ever made.
Until recently, most studies on time travel are based upon classic general relativity. Coming up with a quantum version of time travel requires physicists to figure out the time evolution equations for density states in the presence of closed time-like curves. In Einstein's theory, a closed time-like curve is a curve in spacetime that could be followed back in time, but not forward. In 1991, David Deutsch, a physicist at the University of Oxford, came up with a proposal for the time evolution equations, with special note as to how it resolves the grandfather paradox and non-determinism. However, his resolution to the grandfather paradox is considered unsatisfactory to some people, because it states the time traveller re-enters another parallel universe, and that the actual quantum state is a quantum superposition of states where the time traveller does and does not exist. Another principle that was developed by Russian physicist Igor Novikov in the mid-1980s expresses one view as to how backward time travel would be possible without the generation of paradoxes. According to this hypothesis, physics, in or near closed time-like curves, can only be consistent with the universal laws of physics, and thus only self-consistent events can occur. Anything a time traveller does in the past must have been part of history all along, and the time traveller could never do anything to prevent the trip back in time from happening, since this would represent an inconsistency. While some physicists argue whether time travel is possible, theoretical physicist Carlo Rovelli thinks that time is in fact an illusion, and our reality is just a complex network of events into which we project sequences of past, present and future. The whole universe obeys the laws of quantum mechanics and thermodynamics, out of which time emerges. More on that in another video.